Assalamu alaikum. Hope that everyone is all right during this crisis, and due to the spreading of coronavirus, everyone is staying at home. So I'm starting today an online class lecture for English medium students of Ramadan College. uh, um, my name's Shams Tanvir, and I'm lecturer of Ramadan College. So let's start straightforward actually. Yes. So in this class we'll talk about chapter 8, chemical reaction. It's in the textbook provided by NCTV. uh, it's the English version. So I'm introducing this class in English. So our topic is chemical reaction. So first topic is symbol. A symbol is short form or expression of a single element. uh, it can be a solid, it can be a liquid, it can be a gas. So example is carbon. For carbon, the first letter C, capital C, is used for expressing carbon, or in case of nitrogen it's the capital letter N. It's used for expressing nitrogen. So first letters can be used for expressing symbol, and some symbol includes first two letters, such as Cl for chlorine, or it can be Ca for calcium, etc. So that's the symbol, and a symbol represents a single atom of an element. And let's get to now formula. So formula is the short expression of a molecule which consists of more than one elements. It can be example of potassium chloride, KCl, or it can be sodium carbonate, Na2CO3. It can be sodium chloride, NaCl. So a formula can also express a single element molecule, such as nitrogen, it's diatomic gas. Ozone gas, it's triatomic, O3. It can be oxygen gas, this it's expressed in O2. So it's are single element molecules, only single elements are present, but no other elements are present. If two or more elements present, it will be the formula of a compound. And valency is needed to write the chemical formula of a compound, so please keep in mind. And valency is very much important in this factor for writing formula of compound, so we have to be very careful about that. And let's see some examples of formula and symbol. So here we can see that nitrogen, its symbol is capital N, and nitrogen molecule is N2, and a compound of nitrogen such as ammonia, it's expressed in NH3. So the valency of nitrogen is 3 here, and the valency of hydrogen is 1. We'll come to talk about valency later in this topic. So now let's see these examples. Fluorine is expressed in capital F, and molecule is F2. And if we take a compound hydrogen fluoride, it's expressed in HF. That means both of the valencies of hydrogen and fluorine is 1. And sodium symbol is Na. So sodium has the symbol of Na. So first two letters of the Latin name natrium is used, and a compound such as sodium nitrate, NaNO3. And aluminium, Al, first two letters are used, aluminum chloride, AlCl3. Magnesium, its symbol is Mg, so Mg. And compound such as magnesium oxide is expressed as MgO. That means magnesium has the valency of 2. It's the member of group 2 elements in the periodic table, and and the valency of oxygen is also 2. So the formula of this compound is MgO. And oxygen symbol is capital O, and the molecule is O2. And if we set an example of a compound formed by oxygen, calcium oxide, it's expressed as CaO. And phosphorus, the expression of phosphorus is capital P, and the molecule of phosphorus, it's P4. It's a rare molecule, so I kept this example to understand, to make the students understand clearly. And a compound phosphorus trichloride expressed as PCl3. So these are the examples of formula and symbol in this table. If you look at this table attentively, you can have some clear ideas about how symbols and formulae are expressed, and how the formula of compound varies due to the valency of all the elements. And let's come to the valency now. Valency. So valency resembles the number of electrons present in the outermost shell of an element. So valency deals with the outermost shells of an element, and the electrons which are present in the outermost shells are called valence electrons. So valence electrons are the existing electrons that remain in the outermost shell of an element. It can be one electron, it can be two electron, whatsoever. Valency represents how many electrons will participate in a reaction. So the outermost electrons present in the outermost shell generally participate in reaction. If some elements has one or two electrons, they can donate these electrons to another element, and if some elements have one or two electrons short, they can accept that number of electron from another element, and they can form compound together. So for example, valency of sodium 1, because it has one electron in its outermost shell. And another example, fluorine can accept one electron in its outermost shell because it has one electron short. To complete the octet rule, the students, you already know about octet rule, so I'm not getting into details about that. So the valency of fluorine will be 1 because fluorine accepts one electron, and valency of sodium is 1 because sodium donates one electron. So number of electrons donating or accepting by elements will be that specific valency. So valency, some examples of valency. Now we can see some examples. Chlorine has one valency, silicon has 4, aluminium has 3, calcium has 2, phosphorus has variable valencies such as 3 and 5. Sulfur has valency about 2, 4 and 6, and these are the examples of elements having variable valency or fixed valency. And after sulfur, we can see some examples of radicals. Radicals are group of atoms which act as single ion. So nitrate NO3 negative, we can see a negative sign above this formula. So this negative sign represents that this radical is not a complete compound. It's in ion, so it's not in a complete structure. Actually, it can form compound with a metal ion. Metal ion is actually positive charged, so it will form a compound with a positive charged ion. So the nitrate has valency of 1 because it has only -1 charge, so its valency is 1. Its valency is 1. And let's come to phosphate. So the charge number of phosphate is -3, so it has valency of 3. Bicarbonate HCO3 negative, also its oxidation number and charge number is -1, so it has variable it has valency of 1. Sulfite SO3 2 minus, it has valency of 2. So you can find more examples of valencies in your textbook. Just memorize these valencies, because these valencies are important for your board examination and other examination. You don't have to learn anything outside your textbook, because the textbook is provided by NCTB, and all the questions will come from the your respective textbook. So please keep that in mind, and you can see these valencies here. Let's come into the next topic, chemical equation. Chemical equation expresses the total phenomenon of a chemical reactions by symbols and formula. By using symbols and formula, we can express what's happening in a reaction, what's forming and what's decomposing. A chemical reaction can form something, or can decompose something, or can substitute something. So the occurrence that happens in the reaction, it's expressed by symbols and formula. The total number of electrons and number of elements will be same before and after the reactions. That means, let's look at this example. It's a complete reaction. Here A and B is making product AB. So this left side of this reaction is reactant, and this side of this reaction is product. So the total number of electrons and number of elements, that means how many atoms are participating in a reaction, is same. Here one element or one number of atom A and one number of atom of B is participating, and it's making product AB. So here the total number of the elements are same on the left side and the right side. It should be maintained. Let's come to the next topic, rules to write chemical equation. So to write chemical equation, first of all we have to use an equal or an arrow symbol or direction symbol between reactant and product. It should be used before writing a chemical equation. If more than one substance is present, a plus sign should be used between them. This is the second rule, that if more elements or more substances are present, then plus sign should be used between them. Then let's come to the next rule. If more than one number of molecules participate, then that number should be written before that substance. Suppose if two molecules of nitrogen are participating, then we have to use this number. We have to write this number before that specific element. The total number of elements in both the reactant and product sides should be equal. We have discussed this before. So let's come to examples. Here we are seeing two examples. Hydrogen and oxygen are producing water. Here in second reaction an arrow symbol is used, and in this reaction an equal sign is used. So please keep in mind that if arrow symbol is used, balancing the equation is not necessary, but if we use these equal signs, we should balance the number of atoms or molecules participating in a reaction. So here two hydrogen and two oxygen atoms are making one water molecule. Here in H2O water molecule only one oxygen atom is present, so this reaction is not balanced. So we have to balance this equation with, now in this example we have balanced the equation. Here to balance this oxygen, we put the number 2, but if we put two coefficient here, if we put here 2, then the number of hydrogen becomes 4. 2 into 2 equals to 4. But here on this left side, this hydrogen was not balanced before, but after we have put 2 in the on the left side of the hydrogen, then it's balanced actually. So by this process we have to balance the chemical equations. The details are written in your textbook, so you can check your textbook and get through the details that how a chemical equation is balanced. It's a very easy process, and in some of the classes you should have covered this topic, so I'm not getting into details about that. Now let's come to the next point, addition reaction. So what is addition reaction? Addition means adding of something. So in chemistry, in a reaction that is called addition reaction, 2 or multiple elements are added to form a single single compound. So 2 or more substance gets added together to form a new compound. This type of reaction is called addition reaction. It should be two or more substance. It should be 2 substance, not less than 2. It should be 2 or more substance, and this will form a new compound. So here's the example: hydrogen, oxygen making water, and iron and sulfur making ferrous sulfide, and ammonia and hydrochloric acid are making ammonium chloride. So here we can see that 2 elements are reacting to form a single new compound. This type of reactions are called addition reaction. Next example is combustion reaction. Combustion reaction means reacting with oxygen of a substance at high temperature. If we heat something at a higher temperature, then the oxygen present in the air, it will react with that substance and it will generate a lot of heat. This type of reaction is called combustion. So all of these reactions written here are completed at higher temperature. Heat is applied. If we don't apply heat, these reactions will not happen. So for this reaction, heat is necessary by any means. We can apply heat by flame, we can apply heat by electricity, or etc. So sulfur is making sulfur dioxide with oxygen, carbon is making carbon dioxide, and hydrogen is producing water. So these are combustion reactions. It happens with oxygen. Okay, so next point is substitution reaction. Substitution reaction, substitute means replacement, replacing something with another material. This is called substitution. So in chemistry, in substitution reaction, an element or radical ion is replaced by another element or radical ion coming from another substance. So this type of reactions are called substitution reactions. Please look at this example. Iron is reacting with sulfuric acid. Here this iron, it's substituted in this sulfuric acid. So this hydrogen is substituted by this iron, so it's making ferrous sulfate, and the hydrogen gets separated. And the next example, copper sulfate. This is called copper sulfate. And zinc, copper sulfate. In copper sulfate, zinc is substituted with copper to produce zinc sulfate, and copper gets separated. Now let's come to transformation of energy from chemical reaction. In some reactions, we can if we take a closer look, we sometimes we observe that in some reactions or in some chemical process, sometimes heat is generated or heat is absorbed. Suddenly the container becomes cold, or suddenly the environment becomes very much hot. It's the due to the absorbance or emittance of energy, heat energy. So in chemical reactions, heat can be generated or heat can be absorbed. So in some reactions, heat is generated after completion of the reaction and the container becomes hot. If we take this example, calcium oxide plus water producing calcium hydroxide. So in this reaction, if we complete this reaction in a container, if we can observe that after producing calcium hydroxide, the container becomes hot. This container will become hot. So it's an example of, and a reverse example can be baking soda reacting with citric acid, and it's producing sodium citrate and carbon dioxide and water. So in this reaction, baking soda reacting with citric acid, it will make the container cold, so temperature will be dropped and heat is absorbed in the reaction. Because heat is absorbed in this reaction, so temperature will drop and the container becomes cold. So this type of changes occur because sometimes chemical reaction energy converts to heat energy, and we all know that energy can be transformed, but the total amount of energy cannot be unequal. So the total amount of energy will be same, but energy will be transformed to another type. So here chemical energy is transformed to heat energy. So these are examples of transformation of energy. And our next topic is dry cell. So here here's a picture of dry cell. It's in the textbook of class 8. You can find this example figure. So in this figure we are seeing that there is an outer layer. This outer layer is made of zinc container. It's made of zinc and it's a container. Okay, it's a container. So on the top of this dry cell, if we look at a dry cell such as battery, a battery is also a dry cell. So this dry cell has a top that is called metal cap. So in every battery, if we take a closer look at the positive end, so this positive end always has a metal cap, this type of cap, and inside this container, mixture of ammonium chloride, carbon dust, manganese dioxide is used to complete this dry cell. So the positive end is made of metal cap and the negative end is made of zinc container. So let's get down to details. Components of dry cell: a positive end, metal cap, which acts as cathode, which is called cathode; a negative end, zinc container, it's called anode; and mixture of electrolyte and paste, ammonium chloride, charcoal powder, and manganese dioxide. These are the components of dry cell. Please take a closer look. A positive end, a negative end, and mixture of electrolyte and paste. So let's see the details. The description of dry cell structure. We have taken a closer look at this structure, and these are the details. That the outer body is made of zinc container, which acts as anode. and the shape of the container is cylindrical. Please keep that in mind. The shape is cylindrical. If we see a battery in real life, we see that the shape of the battery is cylindrical. So this body is cylindrical, and the outer layer is made of zinc container, which acts as anode, and the end is and the I'm sorry, I have mistaken. The outer body is negative. Outer body is negative. I should have corrected that. Please take a look at this picture. It's a typing mistake. I'm sorry. So please let me correct that. Okay, so this zinc container acts as anode. It's negative, and the carbon rod applied inside the container, which acts as cathode. So on the top of this carbon rod there is a metal cap, which actually works as the cathode, and the carbon rod is connected in such a way that it does not touch the anode. Please keep that in mind. So to complete the cell, the positive end should not get in touch with the negative end. It must be maintained that the carbon rod doesn't touch the anode. So on top of the rod there is a metal cap, which actually works as the cathode, and inside the container mixture of ammonium chloride, charcoal, and manganese dioxide is kept. So these are the descriptions of dry cell structure, and our last topic is electrolysis. Electrolysis is a process in which chemical reaction is occurred by applying electricity. Electrolysis is a process, and it only occurs when we apply electricity, and by applying electricity we'll observe chemical reaction is happening. So it's a special type of reaction. Here the chemical reaction will only happen if we apply electricity. So electricity is a must for electrolysis. So this in this definition, the electricity is word is hidden actually, electrolysis. So by applying electricity we will get the chemical reaction, otherwise we cannot observe the chemical reaction. And the substance that undergoes chemical reaction in this process is called electrolytes. The substance that undergoes the chemical reaction is called electrolytes. For example, sodium chloride, sulfuric acid, potassium chloride, etc. You can find the details in your textbook provided by NCTB. And the electrolysis is carried out by a specific cell, which is called electrolytic cell. Please keep that in mind. If we apply electricity to obtain chemical reaction, so we should use cells. It may contain which should provide us electricity, so we have to use cell. This cell is called electrolytic cell. It consists of cathode and anode. Okay, so cathode and anode must be present to obtain the electrolytic cell. So description of electrolysis. Here we can see this figure, and this figure is in the textbook. So please take a look here. A container is placed, and inside this container the cathode bar, anode bar, and the cathode bar is placed on both of the end of the container. So at this end, this bar is called anode, and this metallic bar is called cathode. And in the solution, sodium chloride solution is taken. And this both of the anode and cathode are connected by a battery and with a wire to complete a circuit. So this completes a cell. This is an electrolytic cell. It consists anode, cathode, and battery, and anode and cathode are connected by wires to complete the circuit. So if we put this circuit into the electrolytic solution, then electrolysis will start and electricity is producing constantly from this battery, and the electrolytes will get ionized. It will get ionized. We can see the reaction. Sodium chloride is getting ionized into sodium ion and chloride ion. The ions will move along in the solution, and in anode is here anode is positive charged. So negative chloride ion will come into the solution, come into the anode, and it will form chlorine gas. This is the reaction of anode. And in cathode, sodium ion will get attracted because this cathode is negative charged. So positive sodium ion will come and it will accept an electron, and it will produce sodium metal in this cathode. It will get deposited in the cathode. So by applying electricity in this electrolytic cell, the sodium chloride solution gets ionized. In anode, chlorine gas is produced, and in cathode, sodium metal gets deposited. We have talked about that. So this is the description of electrolysis. It's the complete circuit which includes anode, a cathode, and a battery, which all are connected by wires. Okay, so this is the description of electrolysis, and this is the end of the chapter. And for details you can see your textbook. The textbook it's available everywhere. So please everyone stay safe. And this is the end of the slide. Thank you very much for watching this video, and please give like and subscribe to my channel if you want more information and more online classes. And for other class and other lectures, if you have any type of problems which I can solve, I will be definitely glad to help. So please knock me if anyone needs help regarding any specific topic. It can be in college syllabus, or it can be a school level syllabus. It can be anything, and it can also be regarding higher studies. You can knock me if you want. So please everyone stay safe and stay at home, and don't get outside, and please wash your hands regularly. So that's all. Thank you.